Hello, everyone. Today we're diving into the world of loops and how they can make your code more efficient and interactive. We're going to go through 4 programs, each building on the last, to show you the power of loops in Python. By the end of this video, you'll know that loops can eliminate repetitive code and allow your programs to adapt at runtime. Let's start with our first program. Here we're using the turtle module to draw a series of vertical lines. As you can see, this code is quite repetitive. It does the same thing 5 times. We manually write out the same commands, that's these, to make the turtle go turn left, move forward, move backward, turn right, lift up the pen, move forward 5 to get ready to write the next line, and then put the pen down again. So this makes the code lengthy and awkward. This works, but it's not efficient. And imagine if we had to draw 100 lines. Right now, there are 5 groups of these instructions to draw 5 lines. And if we had to draw 100 lines, that would be 100 of these groups. And while we could copy and paste, and we could do that 100 times, if we then changed our mind and wanted to draw lines that weren't 100 units, but were instead, say, 200 or 150 units, we'd have to make that change in every one of those groups of instructions. That's horrible, really inefficient. So let's look at our next example. So in this example, we've introduced the structure of a for loop in order to handle the repetition for us. This loop runs 6 times, which is one more than the last program. It's doing the same instructions that it did for each line, but the for loop causes it to repeat 6 times. See? By using this loop, we've eliminated all those groups of instructions that were making our previous program so long. It's cleaner and it's easier to read. But also, if I wanted to change this to make the lines a different length, like say 150, it's very easy to do so. And there we go. So we can take a step further. Looking at this third program, we're going to use an input statement to ask the user how many lines they want to draw. This makes our program interactive, and that makes it more flexible, allowing the user to decide the number of lines they'd like at runtime and not beforehand. Let's run this. So you see when I run this, I'm going to need to scroll down here. Down in the console, it's asking me how many lines I'd like to draw. Let's draw 12 lines. I've also sped up the turtle there. See, it draws 12 lines. It draws them just the same as it was drawing before. I can run this again, and I can tell it I want 40 lines, and it will draw 40 lines. So this program shows by using a loop to repeat the instructions that draw the lines, my program is more flexible because it can decide what to do at runtime, and we don't have to know when we're writing the program exactly how many lines a user might need. Finally, the fourth program adds even more customization. Here we're asking the user for the number of lines, the length of the lines, the gap between them, and whether they should be straight or tilted. Let's run this program. How many lines would we like to draw? Let's say 100 lines. How long should they be? Let's make them be 150 in length. How far apart should they be? Let's make these lines 2 spaces apart. Would I like the lines to fan out or line up straight? We're going to make them fan out, and we will use an angle of 2 for the tilt. How many pixels thick should the pen be? We'll just make it 1 pixel thick. And here we go. Now we've got a program that has a high level of customization, things that can be decided when the program is running rather than beforehand, and a program can now do a lot more than our first program could do. Yet it's actually not longer than our first program. If we go back to the first program, you'll see that first program was about the same length as this program that is super customizable. Actually, this one is even shorter. Let's go back to program 3 to break down the parts of a for loop. Understanding these components will help you use loops more efficiently. So first, this is the for loop from example 3. As you can see here, the first line we have is the loop declaration. It says for I in range lines. I is the loop variable. That's the variable that changes as the loop is running. It keeps track of which iteration of the loop that we're on. Range lines here creates something called an iterable that holds all the values that I is going to go through. Okay, it's a list of values from 0 to just under whatever lines is to ensure that the loop will repeat the correct number of times. In order for us to take a closer look at this, I'm going to put a print statement in here, print range lines. Okay, and now we're going to print to the console what happens when you call range with the value. So let's run this program. Scroll down. What would I like to draw? Let's draw, in this case, I'm going to draw 3 lines. Okay, there's the 3 lines. And notice range lines produced a list containing 0, 1, and 2. That's 3 elements. That means that if I use the same exact call in the for loop for the iterable, that means that I is going to take on the value of 0, then 1, then 2 every time through the loop. It gets a different value. This indented block here is the body of the loop. This is the code that runs each time through the loop. So these are the instructions that draw one line and get the turtle ready to draw the next line. So every time the loop runs, I is going to take on the next value in the range, and the loop body executes. This is how we efficiently repeat code and flexibly repeat code rather than writing it multiple times or doing a bunch of copy and paste that makes our code long and awkward.